When designing with operational amplifiers, we often start by imagining them as perfect components, able to change their output instantly. It is easy to overlook real-world characteristics that can profoundly impact circuit behavior, especially at higher frequencies or with large signals. Understanding these practical limitations is key to successful design. A critical real-world characteristic is the slew rate, which directly limits an op-amp's output. The slew rate specifies the maximum rate of change of the output voltage, usually expressed in volts per microsecond. If an input signal demands an output voltage change faster than this maximum rate, the op-amp simply cannot respond quickly enough, leading to signal distortion. This limitation primarily arises from the internal architecture of the operational amplifier. Specifically, it is due to the finite current available to charge and discharge internal compensation capacitors. These capacitors are essential for stability but introduce a delay. The input stage of the op-amp can only supply a limited amount of current. Therefore, the speed at which the output voltage can transition is directly constrained by this current limit, divided by the capacitance value. To identify slew rate limiting, look for triangular-shaped output waveforms when the input is a square wave, or a reduced peak output for sine waves at higher frequencies. This distortion indicates the op-amp is struggling to keep up with the demanded voltage changes. When choosing an op-amp for a specific application, it is important to ensure its slew rate is adequate for both the maximum frequency and the peak output voltage swing required. An important related concept is the full power bandwidth, or FPBW. This refers to the maximum frequency at which an operational amplifier can produce its maximum undistorted output voltage swing, typically specified as plus or minus 10 volts or 20 volts peak to peak. The FPBW is directly determined by the slew rate and the peak output voltage. This means that even if an op-amp has a high small signal bandwidth, its ability to deliver large, fast signals might be significantly less due to slew rate limitations. By carefully considering the slew rate and its impact on the full power bandwidth, you can select an operational amplifier that accurately reproduces your signals without unwanted distortion. This ensures your designs maintain signal integrity, especially when dealing with high amplitude and high frequency applications.